Good morning, girls. Today's lesson is about changes in matter. Changes in matter could be physical change or chemical change. Okay? First, we will talk what is the meaning of physical change and what's the meaning of chemical change and examples for each one of them. Physical change is a change that do not affect the matter. What does this mean that it doesn't affect the matter? It means, for example, when you sharpen a pencil, the pencil goes through a physical change. I sharpened the pencil, I changed its shape only, but it's still wood, right? It's still lead, right? So we didn't change it into a new substance. It is the same substance, but we only changed its shape. Okay, like what else? Like water. When you freeze it, it become an ice cube. Okay, the ice cube is still water. Is it a new substance? No, it's not a new substance. It's still water, but it changed its form from liquid to ice. Okay. Like what? Examples for physical change, like crushing a can. When we crush a can, this is a physical change. Melting an ice cube. We changed it from ice cube into water. Boiling water. We changed the water from liquid water to gas. Mixing sand with water. This is physical change. Breaking the glass. When we break the glass, is it still glass? Yes, we didn't do a new substance. It's a broken glass. What else? Dissolving sugar in water. When we dissolve sugar in water, this is called physical change. Still, it is water and sugar. Shredding paper. When we cut a paper into small pieces or small shreds, did we change the paper? No, it's still paper. So we call it a physical change. Mixing marbles, colored marbles, green and red. They are still marbles. We didn't change them into a new substance. Okay? All this is called physical change. What about chemical? Chemical property is the property that cannot be observed without changing the identity of matter. You remember when we said what's the physical property? When we describe something, physical property is its color, its shape, its volume, its mass, its density, its texture. All this is called physical property. We didn't change the identity, we're just describing the matter. Okay? But the chemical property is the property that cannot be observed without changing the identity of matter. Okay? Like what? Like the iron. It is iron, right? We will not observe that it changed except when it changed into a new substance called rust, right? As you see here in the picture. What else? The wood. When we burn it, it will change into ashes. Okay? So we will not observe that there is a change except when the wood change into ash. And here we will not observe that the iron is changed except when we see its color became orange and cracked like this. Okay? So this is rust. So what is the chemical property? The chemical property is a property that cannot be observed without changing the identity of matter. Chemical change takes place when we change the identity of matter. So we have to change the identity to get a new substance or to make a chemical reaction or a chemical change. When a strawberry rots, it undergoes chemical change. Okay? What is the meaning of chemical reaction? It is the process in which a new substance are formed during a chemical change. So in the chemical reaction or the chemical change, we have a new substance. It was a strawberry and then it became a rotten strawberry. Like this, there is fungus on it. It was wood and then it became ashes. So this is a new substance. It was iron and now it became rust. So it is a new substance. This new substance is called chemical property or chemical change or chemical reaction when we make a new substance. While the physical, no, we don't have to change the matter. We just change its shape, its description. Swelling and shrinking. Most matters expand when the temperature is high and contracts when the temperature goes down. So when it is hot, they expand. When it is cold, they shrink. Okay? But water is different. Water expands when it freezes. Here you have a water bottle, a normal water bottle that has a liquid, and then when you put it in the freezer or the fridge, what happened to it? It changed into ice and it expanded to get out of the bottle because ice takes up more volume than the same amount of liquid water. So water expands when it freezes. What about gas? The gas here in the balloon, when it is hot, okay, it expanded, okay, but when it is cold, it is compressed. The balloon will not be filled. So when the gas in the balloon expand when it is warmed and compressed when it is cooled. So gas is different. Gas will compress in cold weather and will expand in warm or hot weather. While water, it expands when it freezes and it shrink when it is boiled. We have the rate of change. What is the rate of change? It's how quickly a change occurs. How quickly a change occurs. What does this mean? Increasing the temperature often speeds up the rate of the reaction. For example, when we are baking a cake, we put it in the oven, so the temperature is very high, so it will quickly change from raw substances into a cake. Another example, when we decrease the temperature, usually it slows down the rate of a chemical change. Why do we put the vegetables and the fruits in the fridge? So we will decrease or we will slow the rate of change that they will be rotten. Okay? We don't want them to be rotten, so we put them in the freezer or in the fridge to slow down the reaction, to slow down the rate that they will be rotten. So increasing the temperature speeds up the rate, like baking a cake. Decreasing the temperature slows down the rate, like preserving the fruits in the fridge. Okay? Again, rate of change is how quickly a change occurs. If we increased the temperature, this will speed the rate of change. Like baking a cake, why do we put it in the oven? To speed the reaction, to make it fast, change from raw substances to cake. What about decreasing? When we decrease the temperature, like inside the fridge, we